Number 5, we're going to be doing some calculations that involve inverse trig functions. And so typically the best way, in my opinion, to handle these is just call them theta. Then what I'm really looking at is this problem. Tangent of what angle theta equals -1. And since I'm dealing with tangent, I can quickly draw a triangle where the opposite and the adjacent are both 1, because this is opposite over adjacent. And this is actually not for theta, but for its reference angle. That way I don't have to mess with the negative sign at this point. And then this third side would be square root of 2. Well, that tells me the reference angle is pi over 4. And then I remember for tangent, you have to put your angles in this way or this way, because that's the, for tangent inverse, because that's the where the range is from minus pi over 2 to pi over 2. Well, because tangent is negative, that means I have to put it in quadrant 4, and I have to go backwards in quadrant 4. So that would tell me that theta, which is tangent inverse, is negative pi over 4 to get it into that quadrant 4. So tangent inverse of -1 is negative pi over 4. Here's another one. Again, I'm going to say what I'm really trying to calculate here is sine of theta. But actually on this one, I don't even have to go that far, because I have sine of sine inverse. So this one's even easier than that. Remember, as long as the trig function's on the outside, these things cancel out nicely, and you just get what's inside there. So it's just using the definition of inverse functions. So, and this has to be well defined, and it is. You can put -1/3 in sine inverse. So as long as all of that works out, you just cancel out. But this time I've got the cosine, I got the inverse function on the outside. So it's not quite going to work the same way. So we've got 9 pi over 5. Well, if it were 10 pi over 5, I would be at, that would be 360, 2 pi. So the angle that we have here is coming all the way around to the fourth quadrant, and it's missing here by pi over 5, because 10 pi over 5 would be 2 pi. So I got to keep that in mind. This is not going to be 9 pi over 5, because you can't get 9 pi over 5 as an output from cosine inverse. Remember, cosine inverse has to give me an output in that interval from 0 to pi. And so I got to figure out, okay, well, this has a reference angle of pi over 5, but because this is in quadrant, this angle was terminating in quadrant 4, this is a positive quantity, because cosine is positive in quadrant 4. All students take calculus, so cosine is positive. And I know that cosine inverse of a positive number is going to put an output here in quadrant 1. And if you don't remember why that is, just think of the graph of cosine inverse. It starts here and goes like that. You see, these are the positive numbers. This is 0 to pi over 2, so output is from 0 to pi over 2 if you give me an input that's positive. So I have to take this reference angle and put it in quadrant 1. Well, that's pretty easy. It's just going to be a positive pi over 5. So I'll get pi over 5. If it were negative, if this had terminated, say, in quadrant 3, then I would have to put that reference angle over here in quadrant 2, because that's where cosine inverse would give me an output. And that would be come back pi over 5, and that would be 5 pi over, 4 pi over 5. Okay, and then the last one, this is what I was trying to do earlier on part B, but this I'm going to replace by theta, and what I'm really trying to calculate is cosine of theta, where theta, I'm replacing sine inverse expression by that. But that's equivalent to saying I want to find the angle such that sine theta equals 3/5. Well, I actually won't find the angle. I'll build a triangle for this. And this triangle has theta there, and the opposite over hypotenuse are 3 and 5, and therefore this third side would be 4. And so I can get cosine off this triangle. From this triangle, cosine would be 4/5. The only question would be, do I have to worry about whether this is -4/5? Well, sine inverse, this is a positive quantity, so sine inverse is telling me this is an acute angle. This theta has to be acute, because theta is either in quadrant 1 or quadrant 2, because that's where sine's positive. But since it's coming from the inverse trig function, we know that sine inverse doesn't give me outputs in quadrant 2. Sine inverse goes these quadrants. So I know it's going to be a quadrant 1 angle, and therefore I don't have to worry about whether this is positive. I mean, it will be positive because of that. But it is something you should worry about.